Assalamu alaikum wa rahmatullahi wa barakatuh. My dear student, today we will discuss about projectile and projectile motion. When a body is projected or is thrown, making an angle theta naught with the horizontal, where the angle won't be 90 degree or 270 degree. 90 degree means the angle created with horizontal anti-clockwise direction is 90 degree, and another angle is 270 degree. Without these two angles, that means theta naught is not equal to 90 degree and 270 degree. When a body is projected making any other angles without 90 degree and 270 degree into the space, then the body is called projectile. If you throw any body, suppose stone, football, shot put, any other body is projected making an angle theta with horizontal, then the body will follow a path, and this path is called projectile motion path or trajectory, and the trajectory is will be actually parabola. So that when a body is thrown or projected making an angle theta with horizontal and into the space, then the body is called projectile, and the motion of the body is called projectile motion. The note here is to be remembered that the angle is taken as horizontal. The angle is taken in the angle is taken anti-clockwise direction, that is theta naught is always taken as anti-clockwise direction. In this case, theta naught is more than 270 degree. In this case, theta naught is 0 degree. If you projected the body along the x-axis direction, that is the angle will be 0 degree. And if you throw a body making an angle theta naught with the horizontal, then it will be more than 0 degree. So that you can say the body will be projected theta naught equal to 0 degree to 360 degree, any angle without 90 degree and 270 degree. Finally, you can say when a body is projected, is thrown in space making an angle theta with horizontal, where theta is not equal to 90 degree and 270 degree, then the body is called projectile, and the motion of the body is called projectile motion. There are so many examples in our environment and in our surroundings. That means when you throw any body, suppose obliquely thrown stone, football, cricket ball, shot put means spear, any disc, any object, any other something, you can throw anything. And angry bird, when you angry bird, when you projected an angry bird in the angry bird games, it will be also a projectile. Properties of projectile motion. There are so many properties, actually 5 properties of projectile motion. One is two-dimensional motion. You can say in this figure, that means the body is the motion is x-axis and y-axis also, so that it is a two-dimensional motion. Here 90 degree and 270 degree is only one-dimensional motion, so that we can omit 90 degree and 270 degree. Otherwise, all the angles, all the conditions will meet two-dimensional motion. Another is limited in vertical plane. The body will go upward and downward. That is, vertical plane is the only plane of the body. Number 3, acceleration is one-dimensional. You know, acceleration due to gravity. When a body is thrown in the space, the only acceleration, effective acceleration, is only acceleration due to gravity. In this case, here acceleration due to gravity equal to g vector, suppose that which acts along the downward direction, and the angle created with the positive x-axis is 270 degree. You can resolve this acceleration into two components. One is horizontal component, x equal to a cos 270 degree, and that is, you know, 2 cos 270 degree means 0, so that x equal to 0, and ay equal to a sin 270 degree, that is g of minus 1, that is minus g. Finally, you can say a vector equal to xi plus ayj. Here this acceleration is two-dimensional acceleration, because the motion of the body is two-dimensional. So you can say a vector equal to xi plus ayj, that is 0i minus 0j. So that you can say if the projectile motion is two-dimensional but its acceleration is only one-dimensional, that means the motion is two-dimensional but acceleration is one-dimensional, and it is a curved motion. You can say this, you can see in this figures, that is, this is a curved motion, this is a curved motion, this is a curved motion, that is projectile motion is curved motion, and the motion path is called parabola. We'll discuss about parabola in the last in the last topic of this in the last part of this topic. Now, condition of projectile motion. Which are the main conditions to meet a projectile motion? The air resistance is negligible or neglected. Air resistance will be zero actually. If there is an air resistance, then it will be actually it will be the motion will be three-dimensional or something else. That is reverse swing motion. And radius of curvature of earth, you know, the earth is spherical, so that the radius of curvature of the earth is not accepted, so that the radius of curvature of earth is negligible, because it is only planar part of the earth, so that the distance of the object is very limited, that is very small with respect to the radius of the earth. And last one is variation of g is negligible, because you know the acceleration due to gravity will differ for the many regions. One is the shape of the earth, another is the height of the object, and the last one is rotation of the earth, so that you can omit the height of the height effect, that is altitude effect. Another is shape effect, that is size of the earth or radius of the earth, so that the variation of g is negligible. There are three main conditions of projectile motions are: air resistance is negligible, number 2, radius of curvature of earth is negligible, and number 3, variation of g is negligible. Now we can draw this figure, and it is the projectile motion. Suppose a body is projected from point O of 0, 0. Suppose a body is projected from O of 0, 0 position, and here with a velocity v naught vector making an angle theta naught in the space, and initially the position of the body are respectively x naught equal to y naught equal to 0, and the initial velocity, that is projected velocity v naught vector, has two components. One is horizontal component vx naught equal to v naught cos theta naught, and another is vy naught equal to v naught sin theta naught. And the acceleration due to gravity, acceleration of the body is ax equal to, you can say axi plus ayj, that is 0i 0j. And suppose the body reaches at point p of xy after t time making an angle theta. Suppose the body, when the body is projected after t time, the body reaches at point p and making an angle theta with horizontal with v vector velocity. So you can resolve this v vector into two components. One is vx, another is vy, so that you can say after t time the velocity, the horizontal component of velocity v vector is vx equal to vx naught plus axt, you know, v equal to u plus at. Similarly, v equal to v naught plus at, that is v naught means the velocity at initial time t equal to 0, which is initial velocity. That means the body, the velocity is taken along the x-axis direction, so that you can say vx equal to vx naught plus axt, and finally vx naught plus 0 into t, that is vx naught equal to v naught cos theta naught. It is the horizontal velocity of the body after t time, vx equal to v naught cos theta naught, that is vx naught. That means the velocity won't change along the x-axis direction, which is uniform velocity, and you can draw a graph which is actually with respect to time the velocity won't change, that is uniform velocity, so that you can say the graph will be straight line parallel to the x-axis or time axis. That is, it is an important question for MCQ equation of intermediate level. And the vertical component of v vector is vy equal to vy naught plus ayt, that is v naught sin theta naught minus gt, and you know vy naught equal to v naught sin theta naught, and in this figure you can say vy naught equal to v naught sin theta naught, ay equals to minus g, that means ax equals to 0 and ay equals to minus g. Putting these values in this equation, you can say vy equal to vy naught plus ayt, that is v naught sin theta naught minus gt. The velocity of the body after t time is v vector equal to, that is the velocity also be two dimensional, which is vxi plus vyj, and the value, that is magnitude of this velocity, v equal to root over vx square plus vy square. And the putting these values from these equations, you can say root over v naught cos theta naught whole square plus v naught sin theta naught minus gt whole square. And it is the most important equation in case of velocity, finding the velocity of the body after t time. and if, so that I can we can denote this equation as the equation number 1. And angle created with horizontal after t time, that is, you can say this velocity, suppose the body reaches at point p of xy and making an angle theta with horizontal and with the velocity v vector, suppose, and this is vx and this is vy, you can find out the angle theta with horizontal, so that you can say tan theta equal to vy by vx, that is v naught sin theta naught minus gt divided by v naught cos theta naught. It is the equation number 2. And now if you can have to find the velocity of the body after t time, then you can use this equation. And if you have to find out the angle created with horizontal after t time, then you can use this equation, that is equation number 2. So that now after t time, the body reaches at point p of x, y, x and y, so that initial position of the body x naught and final position along x axis is x, and initial position of the body along x y axis is y naught equal to 0, but final position is y. That means you can denote, you can indicate the position along x axis and y axis. Suppose this is x and this is y, that means initially the body at point O of 0 0, that is x naught equal to 0, and finally x, you can say x minus x naught is the distance after t time and along x axis direction. And in case of y axis direction, initially the body at point y naught equal to 0, after t time the body reaches at point y, that is, you can say, and the distance, that is displacement of the body along y axis y minus y naught, when it was we know that displacement s equal to ut plus half t square. Similarly, s means in case of x axis direction, you can write this x axis direction, you can write s equal to x minus x naught, and in case of y axis direction, y minus y naught. After that, you can write the horizontal distance and vertical distance of the body after t time. After t time, the horizontal distance x minus x naught equal to vx naught t plus a half ax t square, and x minus 0 equal to v naught cos theta naught t plus half 0 into t square. Finally, x equal to v naught cos theta naught t, equation number 3. And putting the that is this is the another important equation to find out the displacement along x axis direction after t time. And you can find the value of t for putting this value t in another equation, so that t equal to x divided by v naught cos theta naught, equation number 3a. And the vertical component or vertical distance of the body, y minus y naught equal to vy naught t plus half a y t square. And you have we know that s equal to ut plus half a t square, and in case of two-dimensional motion, you can say s means y minus y naught and u means vy naught t plus half a y t square. Putting the values of the different components, that is y naught equal to 0, vy naught equal to v naught sin theta naught, and ay equal to minus g, so that you can say the equation will be y equal to v naught sin theta naught minus half gt square, equation number 4. And now putting the values, the value of t in this equation, you can get u equal to v naught sin theta naught divided by x, v naught x divided by v naught cos theta naught minus g divided by 2 into x square v naught square cos square theta naught. Projection equation, that is, sorry, here in this v naught and v naught will get eliminate, so that finally x tan theta naught minus gx square divided by v naught square cos square theta naught. This is the projectile equation in case of x and y, that is horizontal distance and vertical distance. And if any of the quantity is absent or if is to be determined, then you can use this equation when horizontal and vertical distance are given, or horizontal and vertical distance in terms of horizontal and vertical distance. And is the equation number 5. And here tan theta naught is constant and g divided by 2 v naught square cos square theta naught is another constant, so that you can say tan theta naught equal to v and g divided by 2 v naught square cos square theta naught is another constant c. Putting this constants in this equation, you can say y equal to bx minus cx square. It is the parabolic equation, and when there are two variables, one is x, another y, and there is the maximum power is one variable is 2, another is 1, that is this kind of equation is called parabola. In this case the square is absent, that is with y, so that the projectile will be along a y axis. And if it is replica, if you take a replica, that is the reflection of this equation, y is proportional to minus x square, which will be in the downward direction of the y axis. And in case of y is proportional to minus x square plus x, that is another quantity plus x, so that the equation go along the positive x-axis. Finally you can say y is proportional to x minus x square will be this kind of parabola, so that the projectile motion is a parabola, because it meets the parabolic equation condition, so that this equation, this equation is a parabola, this figure is parabola, similarly this figure is parabola, these figures are parabola, that is only one part of this parabola is taken and another part is absent here, so that you can say this equation y equal to bx minus x square is the equation of parabola. The position vector of the body after t time is r vector equal to xi plus yj, that is r equal to root over x square plus y square. And because suppose the body reaches at point p of xyz, the body reaches at p of xy, this is the r vector position, this is x, this is y, and this is the angle theta, so you can say r vector equal to xi plus yj, and this is the p of xy. And r equal to root over x square plus y square, and tan theta equal to y by x. And now we can say that our parabolic equation are determined, and the equation of projectile motion equation have been determined or expression are taken in the above mathematical expressions. Now there are some important equations in case of parabola, and that is when a body is projected along a o of xy O of 0 point, making an angle theta naught with horizontal, that is it has two components. The velocity of v naught vector can be resolved into two components. One is vx naught equal to v naught cos theta naught, another is vy naught equal to v naught sin theta naught. Because the velocity makes an angle theta naught, you can the velocity of a vector, that is a vector has two perpendicular components, one is v naught cos theta naught, and another in case of two-dimensional motion, and another is v naught sin theta naught. And that is the initial position of the body, x naught equal to y naught equal to 0. And finally when the body reaches at maximum point m, that is the maximum height will be y equal to h, and in this case the time taken to reach the maximum height is tm. And tm, we have to determine this tm. And the maximum height, in case of maximum height, the vertical distance of the body, that is vertical velocity, will be 0, because the velocity vertical velocity will change due to the gravitational effect. And after that the body will reaches at point s point, when the body projected from point O, that is the vertical position is 0. And similarly when the body reaches at point the vertical position 0, that is y equal to 0, you can say this position y equal to 0. Then the time taken is called time period, time of flight, and the horizontal distance is called horizontal range. You have to find out these values. One is tm, another is h, another is r, another is t. These are the four major equations in case of projectile motion. Now time to reach maximum height. When a body is projected making an angle theta naught with v naught velocity, the body reaches at maximum point m after t time. Suppose we know vy equal to vy naught plus ayt, that is v naught sin theta minus gt. You know the velocity vy naught equal to v naught sin theta naught, so that when the body reaches at maximum height, that is y equal to h, that is the velocity vy equal to 0, and t will be t equal to tm. Now putting this values in above equation, you can say 0 equal to v naught sin theta naught minus gtm. Finally tm equal to v naught sin theta naught divided by the equation number 8. It is the equation to find the time to reach maximum height of a projectile. Now maximum height, when we know vy square equal to vy naught square plus 2a as actually, but it is in case of two-dimensional motion, you can say 2ay of y minus y naught. That means when the body reaches at maximum height, the y will be h, and initial y naught equal to 0, but vy equal to 0. Similarly 0 square equal to v naught sin theta naught whole square plus 2 of minus g h minus 0. Finally putting these values in this equation, you can say h equal to v naught square sin square 2 theta naught divided by sin square theta naught divided by 2g. Equation number 9 is the most important other equation, most important equations of these are the most important equations of projectile motion. Now time of flight. What is time of flight? When a projected body returns to its initial vertical height. If you projected a body, if a body is projected from the ground, if the time taken to return the ground is called time of flight. Or if a body projected from the roof of a building, then the time taken to reach the body to the level of the roof of the building is called time of flight, not ground. That is the vertical height, initial vertical height. The time taken to return a projected body of its initial vertical height is called time of flight. So when a projected body returns to its initial vertical height, then the time taken by the body is called time of flight. We know y minus y naught equal to vy naught t plus half ayt square. When the body reaches at the ground, then t equal to t and y equal to 0, because the body returns to the initial height, that is initial ground. The body is projected from the ground, so this it will return to the ground, that is vertical height will be 0. Now putting these values in this equation, that is y minus y naught v naught t plus half t square, you will get another equation, that is y minus y naught plus v naught t plus half ayt square. 0 minus 0, that is v naught sin theta naught t minus half gt square, because after t time the body reaches at the ground, that is initial height is ground and final height is ground, so that you can say y minus y equal to v naught sin theta naught t minus half gt square, and 0 equal to v naught sin theta naught of minus gt by 2 divided of t. Finally you can say t equal to 0, or v naught sin theta naught minus gt by divided by 2 equal to 0. Finally t equal to 2 v naught sin theta naught divided by g. It is the time of equation of time of flight. And now the next one is horizontal range. When a projected body returns to its initial vertical height, then the horizontal distance covered by the body is called horizontal range. And we know x equal to v naught cos theta naught t. If the time taken by the body to return of its initial vertical height t equal to t, then x equal to r. That means when the body reaches at the ground, the time taken is called, that is when a body projected from the ground and it will reaches at the ground after t time, this time is called time of flight, and the horizontal distance covered by the body after t time is called x equal to r. So you can say when a projected body returns to its initial vertical height, then the horizontal distance covered by the body is called horizontal range. We know x equal to v naught cos theta naught t. If the time taken by the body is to return of its initial vertical height, then t equal to t is t equal to t, then x equal to r. Putting these values in this equation, x equal to v naught cos theta naught t, that is r equal to v naught cos theta naught capital T. Putting the value of t, that is v naught 2 v naught cos sin theta naught divided by z. Finally that r equal to v naught square 2 sin theta naught cos theta naught divided by g. Finally you know 2 sin theta naught cos theta naught means 2 sin 2 theta naught, that is sin 2 equal to sin 2 equal to sin 2a equal to 2 sin a cos a. Similar formula, and putting this this formula in this equation, that is r equal to v naught square sin 2 theta naught divided by g. It is the maximum horizontal range. Now maximum horizontal range, the last equation of this chapter or of this topic, and we know r equal to v naught square sin 2 theta naught divided by g. You know the horizontal range of a body is r equal to v naught square sin 2 theta naught divided by g. If v naught and g are constants, then r depends on only sin 2 theta naught. V naught and g are two constants, that is the variable is only 2 sin theta naught. If sin theta naught 2 sin theta naught is maximum, r will be maximum, that is r will depend on the sin 2 theta naught, so that the maximum value of sin 2 theta naught is actually plus 1. So sin 2 theta naught equal to plus 1 equal to sin 90. Finally 2 sin theta naught equal to sin 90 degree, that is theta naught equal to 45 degree. When a body shot put football is projected making a 45 degree with horizontal, then it will cover maximum horizontal range. It is called maximum horizontal range. These are the main equations of projectile motion. Now we can recap the whole topic. Now we can recap this projectile motion. When a body is projected making an angle theta naught with horizontal, the condition is theta naught won't be 90 degree and 270 degree, because 90 degree and 270 degree are throwing body and falling bodies. For they are, that is, in case of 90 degree and 270 degree, the body will follow one dimensional motion. For this reason, we can omit, we can neglect these two angles, that is 90 degree and 270 degree. Otherwise, all our angles are taken to be a projection angle. So, so when a body is thrown or is projected in space, making an angle theta with horizontal, then the body is called projectile, and the motion of the body is called projectile motion. There are so many examples you can find in the environment. That is throwing stone, throwing football, throwing any object, shot put, are the projectile motion. And the conditions of the projectile motions are, that means air resistance is negligible, radius cover curvature is negligible, variation of g is negligible. There are three main conditions. And the projection body, and there are five properties of projectile motions: two-dimensional motion, limited in vertical plane, acceleration is one-dimensional, and curved motion, motion is for this parabola. And why the acceleration is one-dimensional, it is explained in this figure. And when a body is projected, or when in the space, there is an acceleration only which is gravitational acceleration due to gravity, which acts along the downward direction. That means the acceleration due to gravity makes an angle 270 degree with the horizontal. That is, you can resolve this acceleration into two components. One is x equal to equals 270 degree, that is 270 degree means 0, and it is 0. Ay equal to a sin 270 degree, that is 2 sin 270 degree minus 1, that is minus g. Finally, a vector equal to xi plus ayj, that is 0y minus 0 minus gj vector. It is the main reason the body, the motion is two-dimensional, but acceleration is one-dimensional. These are the main equations and topics of the day. So we'll discuss later in by on another topic. Assalamu alaikum wa rahmatullah.